Okay, so let's say now I am trying to find the number of 0. So I have an equation like this: 2x square minus 5x plus 3 equals to this is my polynomial. Now if I need to find the zeros of this polynomial, what I can do is I can first try to factorize it. Now here I take 2x common, then it will be minus 3 common minus 1. So I have got 2x minus 3 here, and I've got x minus 1 here. So let's say if I put x is equals to 1, I can see here that this will become 0, right? P P1 would be actually 0, isn't it? Why it will be 0? Because we'll say that 2 into 1 minus 3 into 1 minus 1, this is minus 1 into 0, which is 0, right? Similarly, if I put x is equals to 3 by 2, then also this will become 2 into 3 by 2 minus 3 into x minus 1, which is 3 by 2 minus 1. This will be 3 minus 3, and this will be 3 by 2 minus 1, which will be 0. So as you can see, when we factorize, it is easier for us to find the values for which the polynomial will become 0. And here, I mean, separately, we could have just said that 2x minus 3 is equals to 0 or x minus 1 equals to 0. And using this, I could have arrived at value 3 by 2 and x equals to 1. So as you can see, whatever being the here the root actually 1, and here x equals to 3 by 2, so I could have just written px again. Just see, if I could have written x minus 3 by 2 into x minus 1 as well, and I could have multiplied it by 2, the entire thing. I could have written it this way as well, right? Well, when we say that px is like this, right? And then I can say that if I can write px as x minus alpha and x minus beta, alpha, this is called alpha, this is a Greek letter, and this is a beta, again this is a Greek letter, and then later on we'll also learn about something called gamma. So it's just like ABC in Greek, and then it is used to I mean denote the variable. So in general, if I'm writing like this, then I can say that alpha and beta are the zeros of the polynomial. So in other words, I can say if alpha and beta are the zeros of the polynomial, then x minus alpha and x minus beta are the factors of the polynomial. So it's other way around. If I'm saying that if I know for which values this particular equation will become 0, then I can just say that x minus alpha would be the root, x minus beta would be the root. So at times we try to find, sorry, x minus alpha and x minus beta are the factors of the polynomial. So at times when we have an expression and we want to factorize it, we just put the values of some numbers to see that which one will be the factor of it. So for example, let's say, let me take an example so that it becomes easier to understand. Say I have got x cube minus 2x square plus x equals to, when this is the expression, and if I need to factorize it, I'll have to figure out as to, okay, what will be the basically values for which this expression will become 0. So for example, let's say I put 1, x equals to 1. When I put 1, I'll get 1 minus 2 plus 1, and then I'll get a 0. So all I can say directly from here that okay, x minus 1 is going to be the factor, is a factor of polynomial. So this is one of the factor of the polynomial it's gonna be. Also, let's say I put x equals to 0 here, then p of 0 would be 0 minus 2 into 0 plus 0 would be 0. So again, I can say x minus 0 is a factor in a way. X minus 0 is a factor. So all I can say is, okay, oh, x is a factor. Basically, x is a factor. Okay, that's all I mean. So px, I've got two factors at least. So I know that there is a factor like a constant is there. There is a factor x. There is a factor x minus 1. And then again, since there is a power x to the power 3, so there will be something more which is gonna be another x minus something alpha or something. Maybe that we need to figure out, right? So all you can do is to figure out what is this alpha. Actually, you could have figured out from
Yes,
here
yes.
itself. Yeah, that alpha is 1. So you could have just written x, kx, and x minus 1 whole square actually. And k is also coming out to be 1. So all I'm trying to tell you here is that if you just know the zeros, then it is also beneficial to factorize this particular expression also. So we'll try to learn about it later as well. Let's move with this equation itself, which is a quadratic. So let's talk about quadratic a bit more, which is ax square plus bx plus c. This is a quadratic I have, and if I have to find out zeros, we will learn something about this. That I said, okay, as we discussed, right? It's a second degree polynomial, so it will have at most two roots. So I can just say that alpha and beta are the roots of this equation, are the zeros or roots of the equation, zeros of this equation. I'm just saying it could be, it could turn out that alpha is nothing or beta is becoming 0. But at most there will be this, there will be two what do you call roots of this. So I can also write px as k times x minus alpha into x minus beta. Then I'll write this as k, and then I'll multiply. This will become x square, then this will become alpha into x, then it will become beta into x plus alpha into beta. And then when I write this, this will become kx square minus alpha plus beta into x plus k times alpha into beta. Now this expression and this expression is same, so I'll compare this. I'll say that okay, x square minus alpha plus beta into x plus k into, sorry, there is also a k over here, k here, k here, plus k into alpha beta equals to ax square plus bx plus c. Since both these expressions are same, so k is gonna be equal to 1, and then minus alpha plus beta is going to be equal to b, and then this k times alpha into beta is going to be equal to c. Now k times alpha into beta, sorry, yeah, k times alpha into beta. Now I'm putting k's values over here, so minus a into alpha plus beta equals to b, and again a into alpha into beta equals to c. Then I will get alpha plus beta equals to minus b by a, and alpha into beta equals to c by a. So this is a very important result which we have arrived at, wherein in any quadratic equation, if you know the two zeros of the uh, polynomial, basically the quadratic, then sum of the roots, sum of the zeros is equal to minus b by a. Basically, minus time coefficient of x divided by coefficient of a. The product of the zeros is going to be equal to c by a, or a constant term divided by coefficient of x square. So you can just write this expression also as sum of the zeros. This is only for quadratic actually, is equal to minus coefficient of x divided by coefficient of x square. Product of zeros would be equal to coefficient or rather constant term, constant term divided by coefficient of x square. So you will see that this is going to be valid for anything. If the expression is like having one root or two roots or zero roots, this is always going to be valid. And we will see how. For example, we will take some simple examples and see. For example, I have one example here, which is x square minus 2x plus 1 equals to 0, or rather px equals to this, which is nothing but x minus 1 whole square, which I know. In this case, for me, the roots are, or I can just write it like x minus 1 into x minus 1. So my two roots are equal, which is like alpha or beta equals to 1. The two zeros are alpha and or beta equals to 1. So if I'm evaluating alpha plus beta, it should be minus b by a, which is mine. So I have to compare it with ax square plus bx plus c. So here I have a as 1, b as minus 2, and c as 1. So minus b by a is going to be minus and minus of 2 divided by 1. So this is going to be equal to 2. Alpha into beta is going to be 1, or rather c by a, which is going to be 1 by 1, which is 1. And when I do this alpha plus beta, since alpha and beta is equal to 1, so alpha plus beta is 1 plus 1, which is 2. And alpha into beta is going to be 1 into 1, which is also 1. So this is more like a verification of this rule that sum of two zeros is equal to this minus b by s, and product of two zeros would be equal to c by a. So this is something which we will keep verifying here. So sum of its zeros, product of its zeros, we just talked about. So for example, we also talked about this. Now they are saying that find the zeros of the quadratic polynomial x square plus 7x plus 10 and verify the relationship between the zeros and its coefficient. So we'll have to verify, which I just did for other one, but let's do it for this one also, and then we will understand. So there is an expression given which is x square, which is this is x square, x square plus 7x plus 10. So this is the polynomial which is given. We have to find the zeros of the polynomial. So first, if I can factorize it, I can actually factorize it like 5 and 2x plus 5x plus 10 versus 0, or it will be x into x plus 2 plus 5 into x plus 2, which will be x plus 5 into x plus 2. And as I can see, the zeros here are basically zeros here would be alpha would be equal to minus 5 and beta could be equal to minus 2. It could be this way as well, that I can take alpha is equals to minus 2 and beta equals to minus 5 as well. It doesn't matter which order I am taking it as. So now alpha plus beta, if I evaluate, it will be minus 5 minus 2, which will be 7. And if I evaluate alpha into beta, it will be minus 2 into minus 5, which will be 10. And as we know from our expression that alpha plus beta is minus b by a, and if I compare it with ax square plus bx plus c, then a is 1, b is 7, and c is 10. And I could see that minus 7 by 1, which is gonna be minus 7 here. This is also minus 7 actually. Alpha into beta is also c by a, which is going to be 10 by 1, and I've got 10, 10. So we are able to verify the relationship between the zeros and its coefficient. This is also done. We found out the zeros as well. And k into x minus alpha into x minus beta. K can acquire any value. So this is k times x minus 1 by 4 into x minus x plus 1. Because it's x minus beta, this is minus 1, minus minus plus it will be. And you can just again expand it. It will be x square plus x minus x by 4 minus 1 by 4, and it would be kx square, and then this will be 3x by 3kx by 4, and this will be k by 4. So this is an expression. So for every value, any value of k, this is, I mean, this polynomial will have roots 1 by 4 and minus 1. Okay. This is how to form it. Similarly, there is another expression, like we are not proving it, but we can as well check it. So it will be if the polynomial is like ax cube plus bx square plus cx plus d equals to 0, then here as we know that there will be three roots at max. So alpha, beta and gamma will be saying are the roots of the equation, roots or zeros of the equation. In this case, what will happen? My alpha plus beta plus gamma will be equal to minus b by a. I'll tell you how to do this also. Alpha into beta, now taken two at a time. Beta into gamma plus gamma into alpha would be equal to c by a. And then all three taken together, alpha into beta into gamma will be equal to d by a. So what do we do here is that if we are taking, it's similar to this. Let me write it right in right side by side. So ax square plus bx plus c, right? So here in this case, there are two roots, right? Alpha, beta. Similarly, I will have one root at a time and then sum it up. So alpha plus beta. So what we do is we just take, when there is one root, I'm taking one root at a time. So what I'll do, I'll just do minus 1 to the power 1 here, just to remember how to remember it. And then we take the, whatever is the second one, like we'll start going from here. We'll write b by a. When it is alpha into beta, because we are taking two roots together, so there will be minus 1 to the power 2 here, and then there will be the third term that I'll be taking into c by a. So similarly here, if I look at here, again I'm taking one term, one root at a time, so it is 1 minus 1 to the power 1, and then the first, basically the second term by first term, b by a. Here minus 1 to the power 2, because I'm taking two together here, and then this will be third term by first term, c by a, and then here it will be minus 1 to the power 3, and then fourth term by the first term, d by a. So you can keep on going like this. For example, if I have a polynomial of 4 degree, like ax to the power 4 plus bx cube plus cx square plus dx plus e, and then there will be four roots here. So I'll have alpha, beta, gamma and delta roots. So if I'm taking one root at a time, alpha plus beta plus gamma plus delta, then it will be minus 1 to the power 1, because there is one I'm taking together, and here it will be b by a. When I'm taking two at a time, alpha into beta plus beta into gamma plus gamma into delta plus delta into alpha plus delta into beta plus delta into gamma plus there will be 3, 3, 6, right? So 4c2, okay. And then there will be 6 here. So this is a repeating. Alpha into beta, alpha into gamma also I have to write. Alpha into gamma also. Alpha into beta, alpha into gamma, alpha into delta. Let me write it in better way. Sorry. First two together. So I'll have alpha into beta plus alpha into gamma plus alpha into delta plus beta into gamma plus beta into delta plus now delta alpha is done, right? Beta gamma is done. So gamma delta. That's all. Now, oops, gamma delta. Now here minus 1 to the power 2, and it will be c by a. Now this is alpha, beta, gamma. 3 together, 4c3. Alpha, beta, gamma, alpha, beta, delta, beta, gamma, delta, right? 4c3. Alpha, beta, gamma, alpha, beta, delta, alpha, gamma, delta, beta, gamma, delta, alpha, gamma, delta. Then it will be minus 1 to the power 3, and it will be d by a. And then all four together, alpha, beta, gamma, delta. And then it will be e by a, and here it will be minus 1 to the power 4. So we just keep on going like this, e by 4. So I didn't do the first one also. For example, if you have px is equals to ax plus b, right? So there is only one root. So in this case, alpha is equals to minus 1 to the power 1 into b by a, which is minus b by a. So this will be the root. So always, this is more like minus 1 to the power 1 second term, basically second term by first term. Here minus 1 to the power 2 third term by first term. This will be minus 1 to the power 3 fourth term by first term. Similarly here minus 1 to the power 1 second by first, minus 1 to the power 2 third by first, minus 1 to the power 3 fourth by first, and it will be minus 1 to the power 4 fifth by first, something like this. So all, you don't have to know the fourth one, at least you need to know this one, this one and this one and this one. Basically this and this you need to know. So you just learned this, and we have given you a formula to know this also. If you can remember in any other ways, that's also fine. Just follow this convention, then probably it will be easier to remember. Okay, but many a times we will see that this cubic equation can be changed to a quadratic equation, and then we will be able to find the roots easily. That's also possible. Okay, so now what we are going to learn, as I was mentioning, that if we can know any other root, then we can even turn the third degree equation into second degree. And to do that, we do something called a long division, and we will learn how to do long division, and then we will try to understand this also. The long division of polynomial. So what we do here is, again, it will be having the same rule, that basically the rule as we have here, right? I mean, if we are doing a division, so we have a divisor, we have a dividend, we have quotient, we have remainder, right? This is this is how we write, right? Dividend equals to. Uh, we'll just show you. I suppose if you know, then that's good. Divisor equals to dividend equals to divisor into quotient plus remainder. Okay. So let's say you have. We'll just start with a simple one. So let's say I have an expression like 2x minus 4, right? And this is my, and my divisor is, this is my dividend, and my divisor is here x minus 2. Okay, so what do I do here is that, again, just like other division rule. So though we have one single expression here in terms of x, then there is no issue, but we have to arrange it in the descending order of the degree itself. So if the highest degree is 2, then of course the degree of the polynomial is 2, then the 2 will come first, and then the first exponent will come, and then second, and all. So here we have to write, like, first we have to write 2x then minus 4, because the constant term will come towards the end. So I'll write like this, 2x minus 4, and all we will be looking at is that how to divide this 2x by this first thing itself. And we know that I can just divide it by 2. So I will write 2, and then we will multiply the first thing by 2x. Then second will be multiplied by 2 as well. Then this will become minus 4, and then we will do as we do this. We will subtract. So this everything will go, and it will be 0. So in this case, my dividend was 2x minus 4, my divisor was x minus 2, my quotient was 2, and my remainder was 0. So this is a simple one, but say, let's say I have this x minus 2, and then I have the divisor is this, and I have an expression. Let me first write the expression. So I have an expression like this: x cubed minus 3x square plus 4x plus 5, right? I have written it in this fashion, wherein I have arranged it from descending in a descending order, like 3, 2, 1, and 0. Now I want to divide it by x minus 2. So what do I do here is that I will write the expression like this: x minus 2, and then try to divide it x minus 3x square plus 4x plus 5. And in this case, I'll look at x and then look at x cube. So for with what value I have to multiply to get x cube? I know that I have to multiply it by x square. So I do this x square. So what I'll get here is x cube. The first thing is multiplied. The second one will be multiplied and we'll get 2x square. And then I'll have to do this minus and then plus. This will go and I'll be left with minus x square plus 4x plus 5. Now when I look here, again I can multiply this x with minus x and I'll get minus x square. So I'll do that, minus x square. Then I'll look at minus 2 and minus x. This will become plus 2x. And then we will do this minus, so plus, minus. This will go and I'll be left with 2x. And then this will be plus 5. Again, I will look at 2x and look at this first term. So I can say that I can just multiply by 2 and then this will go. So I'll multiply by 2. So I'll get 2x and this will be minus 2 multiplied by 2. It will be minus 4. And again, I do this minus plus. This will go and now I'll get 9. Now, x degree here is 1 and here it is 0. So I'll stop here. Once either it is just that remainder becomes 0 or my remainder has a degree less than the degree of the divisor, then we stop here. So what happens here is that I can write the expression x cube minus 3x square plus 4x plus 5 as x minus 2 multiplied by x square minus x plus 2 plus remainder. So dividend is equals to divisor into quotient plus remainder. So this is the way we try to basically divide the polynomial. Okay, so let's do one more wherein I can just simply divide it. So for example, this is the one. This is saying
Okay.
so here they are saying that expression is actually 3x square minus x cube. It's not coming out properly. This is 3x square minus x cube minus 3x plus 5. I have to divide it by x minus 1 minus x square. Okay. So now both of them are not in a proper order. First of all, I have to make the dividend and divisor in the proper order. So first thing is that the highest order has to come first. So I'll rearrange it. It will become minus x cube. Then this is plus 3x square. Then minus 3x plus 5. So this is now in order 3, 2, 1, 0. Now this one also has to come in order, which has to be minus x square. Then this is plus x minus 1. So now this is also in order. Now I try to divide it. So x square plus x plus 1 here. And this will be minus x cube plus 3x square minus 3x plus 5 here. Now I look at this minus x cube and minus x square. So I just multiply it by x, then this will be minus x cube itself. So this will become minus x cube. I look at this will become plus x square. Then the last one will become plus x. I'll have to do this plus minus minus. This will go and this will become 2x square minus 4x plus 5. And here again, if I look at this, if I have to get a plus 2x square, then I'll have to multiply it by minus 2. So if I multiply it by minus 2, I get a 2x square here. But then I get minus 2x here. Then I get minus 2 here. And this will become minus plus plus. This will also go. And then I'll be left with minus 2x plus 7. Now I cannot go further because here the remainder has got a degree 1, wherein this divisor has got a degree 2, so I cannot divide it any further. So I'll have to stop here and then I'll have to write the expression as minus x cube plus 3x square minus 3x plus 5 would be equal to minus x square plus x plus 1 into x minus 2. and the remainder is minus 2x plus 7. And they are asking us to verify, so we can just take the RHS and see. We'll have to multiply this minus x square and x minus 2 to minus x square minus x will be minus x cube minus x square plus this will be 2x square and then plus x square and then minus 2x plus x minus 2 and this will be minus 2x plus 7. So when I sum it up, RHS will be minus x cube, this will be 3x square, this will be 2x, 2x, 4x, and then this plus x, this will be minus 3x, this will be 7 minus 2, this will be 5. So yeah, I mean, after just simplifying it, we again find this value to be true. So this verification is okay, we verified it, right? So basically, first thing is, if you figured out this x minus root 5 by root 3 basically, or whichever way, or x plus root 5 by 3 are the roots of the equation, so then what will happen is that x square minus 5 by 3 is the basically factor of this polynomial, right? Let me just again show you what was the mistake. Here x square minus 5 by 3. Why it became just x square minus 5 by 3 is because this is a minus b, this is a plus b, so this will be a square minus b square, isn't it? Okay, then we'll get to this 3x to the power 4 plus 6x cube, and then it was minus 2x square, and then it was minus 10x minus 5. Okay, so the issue here was I was doing this all right, 3x square. So first thing is that this will come as 3x to the power 4, but this will, when this minus 5 by 3 will be multiplied by with 5 by 3, it will become minus 5x square actually, and it will not be here but rather here. So this will be minus, this will be plus, so this will go off, and this 6x cube will come down, and this will become plus 3x square, and then we'll have minus 10x minus 5, any which ways. So then you'll have to multiply it by with 6x, then you'll get 6x cube, and this will become minus 3, 2, or this will become 10x actually. Minus 5 by 3, I'll write minus 5 by 3 into 6x actually. So it is actually skipping one here. So just we have to be wary of this one. Minus and plus, this is gone. So I've got 3x square here. This will be 5 into 2. This will become 10x. So this will go actually. 3x square minus 5 is left here. Then I multiply it with plus 3 here. Then I get 3x square. And then 3 cancels out. I get minus 5 and minus and plus. So this will go and this will be 0. So now what I've got is this is another expression here. 3x square plus 6x plus 3 there. So now my entire thing, this 3x to the power 4 plus 6x cube minus 2x square minus 10x minus 5 would become x square minus 5 by 3 into 3x square plus 6x plus 3. Now if I can find out this can also become 0. So how it will become 0? If I can just take 3 out here, then this will become x square minus 5 by 3, and this will become x square plus 2x plus 1, which is nothing but 3 times x square minus 5 by 3, and this is x plus 1 whole square. So now I've got the roots. Basically they were asking us to find the roots. The roots are one which is already given, root 5 by 3, another one which is given minus 5 by 3, and then this is another root minus 1, because when x plus 1 whole square becomes 0, it can become only 0 when x is equals to minus 1. So these are the roots. I mean, you can just write minus 1 again, so there will be 4 roots. Basically 2 roots are equal, these 2 roots are equal.